Now we'll do an example of the change of LMT from one longitude to another. In this one, you will see why it is important to have a column for the date. The local mean time at A, longitude 137 degrees and 50 minutes west, is 1812 on the 18th of August. What is the LMT at B, longitude 121 degrees and 12 minutes east? Always lay the problem out in a table and always work through UTC. The first thing to do is to calculate the longitude to time conversion. This is sometimes referred to as the arc to time conversion. You can then work out whether you need to add or subtract to arrive at UTC. When you've done that, click to continue. You should have got that you need to add 9 hours and 11 minutes. This gives you a UTC of 3:23 on the 19th. You can now see why we need the date column. We now need to convert from UTC to LMT at B, which has a longitude of 121 degrees and 12 minutes east. Again, do the calculation and work out whether you need to add or subtract to arrive at LMT for an easterly longitude. When you've done that, click to continue. You should have got that you need to add 8 hours and 5 minutes. This gives a local mean time at B of 11:28 on the 19th. Now, you may have noticed that this question could have been solved without working through UTC. The total change of longitude from A to B is 259 degrees and 2 minutes, which converts to 17 hours and 16 minutes later than A's LMT. Working through UTC as we did may seem longer, but it is very easy to make a mistake if you take shortcuts, especially if the date changes. Always use a tabular layout and work through UTC. However, LMT is unsuitable for keeping on our watches because it varies, as we have said, with change of longitude. Take the United Kingdom, for instance. Suppose that the mean sun is passing over the Greenwich meridian, so that the LMT there is 12 noon. This means that it was over Great Yarmouth 7 minutes ago. Its LMT is 12:07. However, the mean sun will not pass over Oxford for another 5 minutes. This makes the LMT at Oxford 11:55. It will not pass over Swansea, which is at 4 west, for another 16 minutes. This makes the LMT at Swansea 11:44. And similarly, we can work out local mean times at Land's End and Londonderry. So, between Great Yarmouth and Londonderry, the LMT is 35 minutes different. We cannot work like this when we have train, coach and airport connections to make. We need a standard time for the whole of the country. For the UK, that standard time is UTC in winter and UTC +1 in summer. Most other countries keep different standard times, and we shall look at that now. Standard time is defined as the official time in a local region adjusted for location round the Earth, established by law or custom. It is up to the government of each country to decide what time difference from UTC to keep. Many world atlases include a map of world standard times, often incorrectly called time zones. A typical example is shown on the screen. Previously, we have considered that the maximum time difference from GMT or UTC is 12 hours. For administrative reasons, some of the groups of islands have chosen a standard time that crosses the 180-degree meridian, resulting in a time difference of 13 hours. This causes the international dateline to deviate from the Greenwich anti-meridian. You can also see that countries with a large longitudinal extent have no option but to subdivide into regions, each with its own standard time. Typical examples are North America and Russia. The Air Almanac contains 3 lists of countries showing their standard times. List 1 tabulates those countries which are mainly to the east of the Greenwich meridian, and are therefore ahead of UTC. The figures shown should be added to UTC to give standard time, and subtracted from standard time to give UTC. This applies to the other tables also. Some large countries are divided into areas having different standard times. For example, Australia. Some countries operate daylight saving time during the summer months. This is indicated by an asterisk alongside the country name. Note that in all cases, daylight saving time is the addition of 1 hour to the standard time during summer months, normally between April and October. List 2 at the top of page 3 shows those countries that keep UTC. This is followed by List 3, which shows those countries, mainly west of Greenwich, which are slow on UTC. We will start with a simple conversion of standard time to LMT. Given the standard time in Nairobi, Kenya, is 15:32 on 10th of June, calculate the LMT in Madrid, Spain. The exact coordinates are shown in the text box. As before, use a tabular layout and always work through UTC. From List 1 of standard times in the Air Almanac, we see that Kenya is 3 hours ahead of UTC. Therefore, the UTC is 12:32 on the 10th of June. The longitude of Madrid is 3 degrees 42 minutes west. So, to convert the UTC just calculated to LMT, we need to use our calculator or go to the Arc to Time page in the Air Almanac. Round the answer to the nearest whole minute. Madrid is west of Greenwich, so GMT is best. Therefore, LMT Madrid is 12:32 minus 15 minutes, which is 12:17 LMT on the 10th of June. Standard time is appropriate for land. What about ships at sea? We'll finish by looking at zone time. At sea, in order to keep the ship's time related to day and night, the clocks are altered by 1 hour for each 15 degrees of longitude change of position. The datum used is the Greenwich meridian, as shown on the screen. The band of longitude, 7.5 degrees either side of the datum, uses UTC as the zone time. From 7.5 degrees east to 22.5 degrees east, the zone time is 1 hour ahead of UTC. From 22.5 degrees east to 37.5 degrees east, the zone time is UTC plus 2 hours, and so on. This division of longitude continues through to 180 degrees. Note that the numerical values for easterly longitudes are negative, as this is the correction to be applied to the zone time in order to calculate UTC. Similarly, westerly zone time values are positive, since the time west of Greenwich is behind UTC. The zones are also given letters, as shown with the UTC zone being Z or Zulu. Thus 1200 GMT is also 1200 Zulu. When approaching 180 degrees longitude in the Eastern Hemisphere, between 172.5 degrees east to 180 degrees, the time difference is shown as minus 12 hours. Whereas from 172.5 degrees west to 180 degrees, the time difference is shown as plus 12 hours. Therefore, as we saw in the lesson on LMT, when travelling from east to west across the 180-degree meridian, subtract 1 day, and when travelling from west to east, add 1 day. Although zone time is used only at sea, the term Zulu time to mean UTC is also used by military forces and by many aviators. Let's summarize this lesson. Local mean time, or LMT, is the time, as determined by the mean sun, at an observer's local meridian. The datum for measuring the local time is the local noon, which occurs when the mean sun is transiting that particular meridian. It is important because we use it as part of the calculation of the times of sunrise, sunset, and twilight. We can solve longitude to time conversions using either the tables or a calculator. This is known as arc to time conversion. When carrying out these conversions, always lay out the working in a table and work through UTC. However, LMT is unsuitable for keeping on our watches because it varies with change of longitude. We therefore keep standard time. Standard time is defined as the official time in a local region, adjusted for location round the Earth, established by law or custom. It is up to the government of each country to decide what time difference from UTC to keep. You must be familiar with the operation of the tables and be able to convert between LMT, UTC and standard time in different countries. The international date line does not always follow the 180-degree longitude line. But if you look up the information from the tables and follow the tabular layout, date changes look after themselves. Finally, there is zone time, which is kept at sea. It has little practical relevance to aviators, but the term Zulu time, meaning UTC, is widely used. This concludes this lesson on time. The next will cover sunrise and sunset.